So we didn't think multiplication of matrices was hard enough already, and there's a couple more rules we need to be aware of. And this is just some of the rules where they're different, where multiplication or where matrices are kind of different to the general laws of algebra we would have followed before with numbers. So one of these is the commutative law. Okay, generally, if we have two numbers multiplied together, the order that you multiply them in doesn't really matter. So if you have 2 times 3, you get 6, or if you have 3 times 2, you'll still get 6. That's the commutative or the commutative law, but that doesn't apply with matrices, and you can try this out yourself. If we have a matrix, we get A times B, it'll give us AB. This will not equal if we swap the order around, B times A, BA, okay? So they're not commutative. So whether you multiply B by A at the start, or you multiply A by B at the start, you will get a different matrix at the end. So they're not commutative. Okay, so you see that they're not equal. They are distributive. So if you're multiplying out the brackets, remember the capital letters all each represent a matrix. And once you're able to multiply that matrices out, following our rules before, they can be distributive. Okay, and you can see that there. They're also associative. Okay, so A multiplied by B times C will still equal A times B all multiplied by C. Once that order doesn't change, because remember we're not commutative. So if we change that order, we'll not get the same answer, but they are associative in the sense that if we still multiply by A by B first and then multiply by C, we'll get the same answer, okay? And once to follow that order. There's another special thing that we see in the very first video. If we multiply A by B and we get 0, that can happen if A doesn't equal a null matrix, or even B doesn't equal a null matrix. So generally in normal terms, anything multiplied by 0 would give you 0, but here we can get 0 by having numbers in our matrices. So that's a useful law. Final law we're looking at is I. We brought that to our attention. That's the identity matrix, and this is the only case where the commutative law is broken here for matrices. So anything multiplied by the identity matrix will equal itself, no matter if it's post-multiplied, so it's multiplied after, or pre-multiplied. So you see we're doing this here, we're swapping them around. They will still equal A. That's only when we're doing it with the identity matrix. Any other matrix, it won't work. So the identity matrix is very important. It's the only one that breaks this rule here, the commutative rule. But that's a couple of rules that we need to be aware with matrices. It may seem a little bit complicated, but it does help down the line when we're using matrices maybe to solve some engineering examples. These rules can be very interesting to us and give us some very interesting results.